Here we go. We have a question kth element of two arrays. So you have given two sorted arrays A and B and an integer k. Our task is to find the element that would be at the kth position of the combined sorted array. So we have given these two arrays and we need to find the fifth element. So first we have this, then this, third element is this, fourth element is this, fifth element is this. So the answer is 6. So we have this also. So in this, this is the sorted array and the seventh element is 2, 5 and 6. So that's about the problem statement. Let's try to build the approach. So I have already solved this question using C++. So you can check the video in the I button. In this video, I'm gonna solve this question using Java. And there are many approaches to solve this question. The brute force will be to check is to combine all those in is to combine these two arrays in separate array and then find the fifth element. The next approach will be to use priority queue and add each and every element. But we're gonna apply binary search. How? Let's find out. We need to find the fifth element. So there are 5 elements there. So let's say we have L pointing to 0 and R pointing to the last element. So now let's find out the middle. What's the middle? So let's give it indexes. So 4 by 2 is 2. So middle is this. So I'm gonna make a cut here. I'm gonna make a cut here. So some elements are there, some elements on the right hand side. So 2 elements on left hand side. And we want 5 elements. So we need to pick 3 more elements. So we will pick 3 more elements in array 2 from array 2. So we will make a cut at this position. So now we have 5 elements on our left hand side. This is our L1 means the left element on array 1. This is our right one means the right element on array 1. This is L2 means left element on array 2. This is R2 means right element on array 2. So we need to check, is this the correct cut? How do we check? If this element is smaller than this, yes, then is this element also smaller than this? No. Why do we need why we need to check this? Because if I add all the elements here, so we have 5 elements here and the remaining elements on this position. So all these elements have to be smaller, but this is not the case. So this is not the correct cut. So we need to mm, find our correct cut. So this is not the correct cut. Is this element smaller than or equal to this element? Yes, this element is correct, but this condition is not correct. Means we need to pick more elements from array 1. We need to pick more elements from array 1. How do we check? If our L2, this is L2, if this is greater than R1, if this is the case, we will move ahead. We will update our L2 mid plus 1. And what's the correct cut? What's the correct cut? If our L1 less than or equal to R2 and our R1, sorry, L2 less than or equal to R2. If this is the case, we have our correct cut. This is the correct cut. But this is not the correct cut. So we have a else if. So as you can see, this is not the correct cut. Or you can write it like this. This is right, but this is wrong. Means our L1 is less than or equal to R2. Yes, L1 is less than or equal to R2. So either you can write this or you can write like this. L1 less than or equal to R2. So we need to pick more elements from array 1. If this is not the case, we will pick less elements from array 1. So in this case, we need to pick more elements. So L will be mid plus 1. L is now pointing to 2. So we got mid. Mid is 3. So we're gonna make cut here. So we have some elements here, we have 3 elements here, and we have 2 elements here. 2 elements from this. So is this the correct cut? This element is smaller than or equal to this. Yeah. This element is also smaller than or equal to this. Yes, this is our correct cut. Then what's the value? What's the returned value? The returned value is the fifth element from the right, from the left hand side. So what's the fifth element? Either this element or this element. The maximum of between these two elements. So the maximum between L1 and L2. So this is about the binary search, but you can improve this. How? We are applying binary search on the bigger array. If you apply binary search on the smaller array, this will improve the time complexity. So just need to check if n is greater than m. So just swap the elements, swap the arrays a2 and a1. So this is just improvement. But there is one more thing. Suppose our k. Let me change the pen. If our k is 5 and there are 10 elements here, and there are 4 elements here, then our L is this, R is this. But do we really need 10 elements? Actually, we don't need 10 elements. We only need 5 elements. So here we have 10 elements. Actually, we will swap it, but still, let's say we have 10 elements here also. Actually, let's say we got more than 10 elements. So do we really need 10 elements? No, we just need to find fifth element. So only 5 elements will work. So just update your R to fifth element. So R will be the minimum of either n or k. If we have only 4 elements here, so we need at max 4 elements. But in this case our n is greater, so we just need 5 elements. So this will work, and we can also improve our L, our lower bound. So let's suppose we got let's say we got mm, let's say we got 6. So from so we got 6 and we have 5 elements here. So we only have 5 elements there, so we need to pick here we have also 5. So in this case we need to pick one element. No matter what the case, we need to pick one element from this first array. No matter what the case, we need to pick, because there are only 5 elements there. So we need to pick one element, we need to pick the remaining elements. So k minus m or 0, the maximum between these two things. So this will improve our binary search. So now let's code this. So we got nm. So I am taking min max, I will tell you afterwards. So if first array is greater, so we don't need this, we want our first array to be minimum size. So binary search on the smaller array. So this is the improvement, maximum between this and minimum between this and this. So then we have our while loop. Just find the middle. If middle element from array A, so we are taking till middle elements from array 1 and the remaining elements from array 2. So if we are making a cut, on the 0th, so left hand side we don't have any element. So for that case we are taking minimum value, else we are taking this. Same for R1. If we are making a cut on the last array, so there are no such elements after that, so we are taking maximum element, else we are taking this. Same applies for array B, but in this case we are taking the remaining elements from array B. So k minus mid, k minus mid, and here also k minus mid. Then we have this condition. If this is the correct cut, just return the maximum. This is not the correct cut. This condition is true. So we want to pick. So we want to pick. So if L2 is less than or equal to R2, means we have this thing. So this thing is true. This thing is true, but this thing is not true. So we need to pick less elements from array 1. So we are taking less elements. Else we are taking more such elements from array 1. So this is the case. Now let's code this. Let's submit this. And now let's talk about time and space complexity. So we have this code, and in this code we are applying binary search on the smaller array. Smaller array is n, so it will be log n, and the space complexity is constant. Now let's find out. Yeah, we have met the expected time and space complexity. If you have any doubt, feel free to ask in the comment section. Code is given in the description box. Thank you all for watching.